Excellent. Okay, if everybody wants to take their seats, we will proceed with the next talk. And it gives me great pleasure to introduce John Cleary to you. And John's going to be talking about what is SNP testing and how can it enhance a Y-DNA surname or genealogy project. Now, John is a lecturer at a university in Edinburgh, a member of the International Society of Genetic Genealogy, whose stand is just here opposite us. And he gives talks on using DNA for family history research in Scotland. He's interested in how genetic genealogy can help to uncover the origins and the spread of surnames. And certainly SNP testing is very, very important in that regard. But John also is involved in a project researching the fate of Scottish prisoners captured by Cromwell in the Civil War and transported to America. And he's working with the prisoners' descendants using DNA and genealogy to discover more about their fate and find out where they came from. And you're using SNP DNA testing as well, to a limited extent?
We are using some, yeah, it's mostly STR.
Okay, but here to talk to us today about SNP testing is John Cleary, so please give him a warm welcome.
Thank you, Morris, and thank you everybody for coming today. I realise there's a very heavy background noise in the hall. Can you hear me clearly? Everyone in the back, yeah, that's great. If you can't hear me, just put your hands up and give me a signal. I am going to give a beginner's level talk today. So if you are somebody who has maybe done STR testing, 37, 67 markers, even 111 markers, you're thinking of doing a SNP test, then this talk will be for you. Maybe you've done the big Y and you're not quite sure what sense to make of it. But anyway, if you're at the beginning of your journey doing SNP testing, then this talk is aimed at you. I have done more advanced level talks about SNP testing here in the previous 2 years, and they're online on the Who Do You Think You Are Live DNA YouTube channel. So if you want to go and listen to those earlier talks, they're available. But this one, in a sense, I'm going backwards from the higher level down to the introductory level. So today we're going to look at how you can start out with SNP testing. So, just to start doing a couple of quick definitions, I'm sure you're all familiar with STRs, what STRs are, short tandem repeats. And I have a diagram here, very nicely drawn by Mark Jobling, who'll be giving a talk in that theatre in 1 hour's time. Do go and see it. And this illustrates very nicely the way STRs work. We have a repeating strand here of these bases on the DNA, CTA, 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 and you can count the number of times it repeats. And these vary, so all of us will have fewer or more STR repeats on some of our markers, on some of our DNA. If you're male, you'll have a Y chromosome, and you'll have STRs on those, same as all your chromosomes. And these are the ones we're interested in for surname research. If you've done an STR test and joined a project, it's gone, come back. Bit too slow there. You'll be familiar with the project results matrix, and these numbers are essentially numbers of times a particular STR repeats. And in the early days of Y chromosome genetic genealogy, that's what you did. You counted these things, and you compared your number with somebody else's number, and you tried to find patterns in those numbers. SNPs, on the other hand, are single point mutations somewhere on the DNA. Illustrated here again from Mark Jobling's diagram. The norm in this position will be an A, but this strand here has a T. That's a mutation. And the thing about these mutations is once they occur, they tend to stay, not forever, because forever is a very long time, but they will stay for a very, very long time indeed. So the STRs, they're not very stable, they're changing up and down all the time. Whereas these things, if you find them, they stay there. And it means you can begin to track them as they appear down a descent line. So these are known as SNPs, sometimes SNP, but where I live in Scotland, the SNP means something quite different, so I use the term SNP, and that's what many people refer to these as. So, there we go. These are the samples there. And this, of course, is a little model of the DNA molecule, part of it, and these are the bases which link the two helixes, and they link in pairs, so each base, each letter here, pairs up with another one, and it's one of these that would change. Somewhere down here, a SNP occurs, and one of these bases changes into one of the other three. And of course, we represent these by the letters A, G, C, and T. And we talk about mutations from an A to a C, and so on, That's just the technical details, don't worry about that. The most important thing is recognizing where there is a mutation and then tracking the history of that mutation. So the Y chromosome then is one of the 23 pairs of chromosomes. Actually, the sex chromosomes, the X and the Y, or the two X's, X and Y if you're male, two X's if you're female, are here. The Y chromosome in men is this little stubby chap here. It doesn't do very much except make you into a man. That's all it does, really. But it means that you pass it on intact from father to son, because it doesn't recombine or reshuffle with other chromosomes. And that means for our purposes, that's very useful. We can track this coming down the male line, not changing very much, a little mutation here and there, which we can trace. That helps us to do some genetic tracing as well. All the chromosomes, they reshuffle with each conception, and therefore tracking them is much more complicated. And talking about the Y chromosome, this little model of what the Y chromosome looks like, it's important to understand that we can't find SNPs on every part of it. We can't read the whole Y chromosome. There's actually about half of it is just repetitive sequences that can't be read. And therefore we disregard this part, and we focus on the parts that can be read. Even within that, this part here, there are different regions, and I won't go into details of what these regions are, but essentially the yellow ones and the blue ones tend to be the best for hunting SNPs, which are reliable and which we can track down the Y line. The pink ones, these stripy bits, we disregard those because they tend to be very similar to other chromosomes, such as the X chromosome. Therefore, we can't be sure that if you find a SNP, it's really on the Y. But in the blue and the yellow areas, we know, therefore, we found a SNP and it belongs on the Y chromosome. So, essentially, there are 60 million positions on the Y chromosome. Once we rule out the ones that we can't really read very successfully or very clearly, we're down to about 25 million. Now, that's all. Now, think of how many men there are in the world. Far more than that, which means that mutations are quite likely to be repeated all the way across the world. Therefore, what we're looking for is patterns of mutations, SNPs, that come together in a way that marks out a descent network. And that's how we're doing our job here. So then, when you find SNPs, they're given names or labels. And many people know some of these labels. If you're a male, if you are in the very large group L21, you may know you have that particular marker. It's a very ancient SNP, about 4 or 1,000 years or so old, back in prehistoric times, and shared by many people across Europe and North America and other parts of the world. Of course, we're interested in SNPs that are much more recent, but it's worth getting your head around the way you refer to SNPs. You refer to SNPs by these labels. They sound a bit like numbers from a catalogue, and if you're not very good with numbers, they can be quite difficult to keep in your mind, but they are the way in which we identify these things. However, you can look up SNPs in a SNP catalogue. I have an example here, a very good SNP catalogue that is supported by ISOGG, the International Society of Genetic Genealogy, over here, and run and maintained by Thomas Krahn, a German researcher in genetics, and it's called Y-Browse. And if you know the position of a possible SNP, or the name of a SNP, you can look it up in Y-Browse. I have an example here showing a SNP we'll look at in just a moment. And you can get information about whether this SNP is known. For example, you may do a test, you may find you have a SNP in a particular position. You can go here and find out if anybody else has that SNP, if it's known already, or if it is a completely new SNP in your lineage. So you do research. We base our search on what's known as the human reference sequence, which is the idealized model of human DNA that's revised constantly, but it gives a map of where the various positions, the A's, C's, G's and T's are on the Y chromosome. So we know where we can track a SNP when we find one. And as I mentioned, each position on the Y chromosome has a number. Essentially, as we look at that diagram I showed you, reading left to right, starting at 1, going up to 60 million. And if you know the number of a SNP that you found, you can put it into Y-Browse, Just type a number like this. You have to do it in a certain way, because this is supposed to be a range, but I'm typing the same number in twice. So I'm looking for a SNP at number 8,796,078. Does anyone know what SNP that is? Don't worry, I'll show you. There's one to research. Up will come the window I showed you earlier, showing us this is a SNP generally known as U106. Again, another of these very major ancient descent markers, several thousand years old, from the Neolithic in Europe, but again, shared by many men in Europe today and worldwide. And you also see that actually there's more than one name, and that's a big problem actually in SNP research, because many labs will discover a SNP at the same time as somebody else, or even later than somebody else, and give it their own name. So these things tend to pick up multiple names. But luckily, Thomas Crown is collecting all these. So you can look them up here and find out what SNP the one you know may also be known as, where it is, and whether it's actually well known and widespread. Now you can also zoom in or zoom out on this catalogue. I've done this here. This is all live online, by the way. I'm showing screenshots. But here we can see the same SNP again, U106, with its alternate names in its sequence. So here is a sequence in which it fits. And scanning down here, we see that this position should be a C. And in fact, this SNP, the C changes to a T, and therefore that is a mutation. In the men who have this particular mutation, the C has become a T. That happened 4,000 or 5,000 years ago. There are many descendants around the world, some of you probably, they have this, and we call this U106. So, this is how to approach examining SNP data. If you do a big Y, you have a list of SNPs that your big Y or your male relative's big Y has shown up. You can then put these into Y-browse and see if they're known already, or if they are in fact brand new SNPs discovered in your test. Many people discover new SNPs in their test. I discovered about 40, only because I was the first person in my line to be tested. So, why do Y testing? Morris mentioned earlier that I'm interested in surname research, and of course the Y chromosome lends itself to surname research because the surname is generally passed down in the same way as the Y chromosome down the male paternal line. That's changing. Surnames are being passed down in different ways today, so the link between the Y chromosome and surname transmission is going to be different in the future, and is different in many other societies. But in the UK, in Britain, in Ireland, we can research surnames this way. And of course, the mitochondrial DNA comes down the female line in the same way. So these two forms of DNA allow you to research these particular lines. Because there's only one line of descent, and we have many hundreds or thousands of ancestors and ancestral lines, but autosomal DNA can access some of them only back to a certain point. So the autosomal DNA tests, like Family Finder, will allow you to get back maybe 5-6 generations before the signal begins to become confused. But the great thing about Y chromosome and mitochondrial DNA is that these lines stretch back almost indefinitely, practically indefinitely, back through human history. You can track the Y chromosome or the mitochondrial DNA line right back to the beginning of Homo sapiens. People have done that, and they've built backbone SNP trees showing the descent of human populations by doing this down these two lines. And of course, within genealogy, you can do the same. Your window may be 300 or 400 years rather than 40, 50,000 years, but you can do the same thing using the same tools of research. And here's a little illustration of a surname I'm interested in. I am one of the administrators of the Cummings surname DNA project, and we're researching various lines who have the name Cummings. It's a very good Scottish name. You find it in England as well, but it's a very Scottish name with concentrations down in the southwest and up in the northeast around Aberdeenshire and Murray. And it's also a name found in Ireland. And in Ireland you have interesting signals because there are Scottish settlers, descended settlers who carry the name, And they're also native Irish, the name coming by different roots. So again, DNA SNP testing can untangle these different types of Cumin origins from each other, as well as helping modern-day Cumins to find out which line of Cumin they belong to. And we'll see a Cumin SNP DNA tree a bit later on. So how do you go about testing SNPs? There are three main types of SNP tests available to you today. And the most powerful, but also the most expensive, is Ngx Next-Generation Sequencing, when an attempt is made to read not the whole Y chromosome, as I said, that's not possible, but as much of the Y chromosome as possibly can be read. And so the big Y test run by our friends over here, Family Tree DNA, comfortably reads about 12 or 13 million of these 25 million positions, so it gets about half of the readable Y chromosome is read in sequence, and because it's read in sequence, it can be compared with the reference sequence, and you can see where there are SNPs on those sequences which are read. Unfortunately, because of cost reasons and speed reasons, they don't read the whole readable Y, but they read a very major segment of it, and one that's proved very, very useful for genetic genealogy. You can also test individual SNPs on their own. So Family Tree DNA and other companies will do a test on a named SNP for you. If you think you may have it, these tests used to be the way you had to do it. It's known as Sanger sequencing from the method used. It's slow, a bit cumbersome, a bit expensive, particularly if you're doing a lot of these things. And therefore, there are other better methods these days, including so-called SNP panels or SNP packs, which are single tests by a technique called mass spectroscopy. Don't get your tongue around that one, which will test you for a whole suite of 120 or more SNPs all in one go. And the difference between this one and this one is testing what you have. It's reading your Y sequence and seeing what's there. It may discover new SNPs. This one is a test based on SNPs discovered via this. In other words, they are all known. And it's testing you for whether you have any of these known SNPs. You may or may not, but it's not going to discover anything new. Of course, this is much cheaper to do than this. So again, when weighing up what kind of SNP test to take, there are big decisions to be made, and I would always advise people talk to an administrator of a project or somebody who's involved in SNP research to get advice about how to go forward. Because if you do a big Y, it's a great test, but you are making a major investment and you want to make sure that that's worthwhile. So do talk to people who are already involved in this form of testing. That's a bit of mass spectroscopy for you. Put a little pause there for a titter. And various companies will do specialist Y chromosome tests. There are other companies who do Y chromosome testing. I haven't listed them here, but these are the ones who do specialist Y chromosome tests for the genetic genealogist. In other words, they are doing tests that will enable you to get data to ask questions about genealogy. Family Tree DNA have the biggest suite of all. They do all three of those types of tests. They're over there. There are other companies also who do what I call niche tests. They do some of these SNP tests. They do them in ways that are maybe for specialists to ask specialist kinds of questions. Family Tree DNA would be the base level where you would go if you were beginning with SNP testing. Family Tree DNA also give platforms to support projects in Y chromosome research, surname projects, and haplogroup projects. And the advisors, the administrators of these projects, will be the people who can give you advice on what type of test and also which company to go to. So I mentioned projects here. Once you've done a test, you're not on your own. There are various third-party analysts you can go to, such as this organization, yfull.com, who take the big Y data and they analyze it for you, they review it, they may discover new SNPs that Family Tree DNA may not have found, and they will then present it to you in a user-friendly and readable fashion. I would still advise you to get advice in how to interpret the data that yfull may give you, but they are there as an add-on to make more sense of the big Y or SNP data that you may collect. There are also, of course, the projects that are all supported directly by Family Tree DNA. This is the general R1b project, R1b being a major haplogroup defined by a SNP, encompassing the vast majority of Western European males. And of course, there is a whole suite of smaller projects underneath this, which are the branches of R1b. And again, the expert administrators here can advise testers whether it's worth doing a SNP test and what kind of SNP test it may be worth doing. So I've got a few little terms I've mentioned here. There's a lot of terminology to pick up in this field. We don't want to blind you in science, bamboozle you, but there are some very useful little terms to keep note of. We're looking for SNPs, and SNPs may be shared or private. Once you get your results in Big Y, you may find you have private SNPs which occur only in your test. Of course, they're private only to your test, not to you, because you probably share them with other relatives who may not have tested yet. But if you're the only person in your family who has tested, then these SNPs will be private in the sense that nobody else will have done a test with them in. And of course, these will be the more recent SNPs occurring in your family branch, which are the genealogists you'll be interested in. And those are the ones you may focus a lot of your attention on once you test it. Shared SNPs also important. A shared SNP can be shared by 2 people, or thousands or hundreds of thousands, depending how far back in time it is. And of course, you may find you share a SNP with 2 or 3 other people. That's quite interesting, because that would suggest that it's not a very, very old SNP. It's not private, but it's recent enough to maybe occur in historical time, or even in the period we call the surname era, the era since surnames were adopted and used en masse, round about, say, 1400 in England, a bit later in other parts of the Isles. I've mentioned this SNP already. This is U106 again. Just to remind you that there are SNP coordinates, which are the numbers on the Y chromosome, and that's how a new SNP, will first be identified. It will come as a number and a little code showing what the mutation is, here a C becoming a T. And of course, once you have your SNPs, you can get them names. You can send them to Thomas Kran of Y-Browse, who'll give them a name. His names all begin with A. And there are other organisations who will also slap names on SNPs. Unfortunately, some of these will slap names on ones that have already been named by somebody else. It's a bit of an arms race in SNP naming. And as a result, the numbers, each name, by the way, will be a letter to tell us what group or lab the name has been given by. And a sequential number, obviously U106, only 3 digits, that's a very old discovery, more than 10 years ago. Whereas these days, FGC here have 5-digit numbers, FGC 3259, and so on. And these can be quite mind-boggling. As for myself, I'm not really convinced a name like that is any better than just having the coordinates. It's a big number either way. But there's no more obvious, easier way to name SNPs, and we need to have some kind of label to show that this has been found, identified, it's in this line, it's in the catalogue. And therefore, labels like these are attached to new discoveries as they're then entered into the Y-Browse and other SNP catalogues. So I want to give you a couple of case studies, just to show you how SNP testing can aid genealogy. I'll just check the time to make sure I don't overrun. Good. So since you're presumably interested in SNP testing for genealogy, I'm going to give you some examples of how I've used it, working with people to solve genealogical questions that couldn't be solved by other means, documentary research, or by other conventional forms of Y chromosome testing. So, first of all, let's look at a test, shall we? This is an STR test taken in 2012 by a man, let's call him Cleary. And this Cleary discovered he matched nobody at either 111, 67 markers, or 37 markers, nobody at all. There was a single phantom match down at 25 markers, but even that's 2 out of 25, it's not really very close. And we found once we got up to, because this Cleary's me, once we got up to 111 markers, we were 18 apart. So not really very close. However, the other match also wasn't called Cleary, it was called Mr. Gorman. And Mr. Gorman insisted that we were related, because he also noticed that the two of us shared a rather unusual marker value. This is normally 13 in R1b men, we're 11, and therefore he argued that the general closeness of our DNA and this rare marker value suggests that we were therefore related. Now, 5 years ago we assumed that if we were close, if we're related on STRs and shared an unusual STR, that must be a fairly recent occurrence. And therefore Sean, as his name, was of the belief that he and I were closely related within the historical period, maybe even within the last 200 or 300 years, and that I wasn't a Cleary, I was a Gorman. I said, well, maybe it's the other way round. But he said, no, clearly you're a Gorman, really. And we pointed to the fact that both of our families come from the same part of Tipperary, Southern Tipperary, between the town of Cahir, the Galtee Mountains, and County Cork. And therefore, we also discovered that there was a Cleary tenant who may be related to me, living on the land of a Gorman landowner. And to Sean, that was there we are, QED, clearly, that's what happened. Well, I thought there was more to investigate in this, so I began taking more tests, and I moved to the big Y test. Oh no, sorry, I'm skipping a step. First I found another Cleary. I felt a bit lonely being the last of my tribe, so I thought, let's go and get another person who's definitely related to me, has my surname, is believed to be a relative by my father and our family, and we'll test him. And we did the documentary research, we looked at the family trees. I'm quite fortunate because, unlike many country Irish families, I can take my ancestry back into the 18th century, because our ancestry is written in stone. There is a gravestone in a ruined church, actually inside the ruined church, in a little townsland called Rochestown, guarded by the most fierce bull I've ever met in my life. And I and my uncle took our lives into our hands about 5 years ago and thought, are we going to do it? Can we come this far and not go there? No, okay, we'll run. And luckily the bull was too concerned with filling his stomach, so left us alone, and we found the stone we're looking for. So we do have a record back to the 18th century. But the other Cleary branch doesn't have this. They get back to the middle 19th century, and then their trail runs cold. But we're believed to be family. And with a couple of possible theories about who the ancestor could be, and so we then moved to testing. And what we found, unfortunately, was not conclusive. According to Family Tree DNA's criteria, I still don't have any matches. And the reason is we found that on one particular marker, we have a 3-step difference. And therefore, on a 37 marker test, we are 6 out of 37. That's our genetic distance. And Family Tree DNA do not rate that as a match. They don't even rate that as being close. Now, and yet, the other general similarity of our haplotype suggests we probably are. Family legend suggests we probably are. Nothing was proven. So next time I moved to Big Y. And as I mentioned earlier, I had 40 private SNPs, a great chain of them, stretching right back to about 4,000 years ago. And eventually more people were tested, and some of those got knocked off, became shared, were proven to be quite distant. But still, I had a long stream of SNPs here, which are all mine, all mine. And then I tested my cousin as well on the Big Y, and he shared almost all of them except for one. There's only one here that he didn't have. That's my private SNP, that belongs to my particular branch of Clearys, but the fact there's only one, he has no I, one, that suggests that we're probably not far away at all. And we think, in fact, the branching point is likely to be around about 1800. So we do have a common ancestor, only about 200 years ago. We still don't know who he is. So if you ever find out, do let me know. I'd like to know. But this is the first stage, but we also have Mr. Gorman over in the USA, and the question is he going to spring off here as well? Is he going to be a Cleary after all? As it happens, no he's not, and nor am I a Gorman. We found that when Sean did the Big Y test, he also had a long stream of SNPs, and an enormous number that he didn't share with me. So in other words, this is the point at which we share SNPs, and from here onwards, those are Clearys, those are Gormans, and they're quite different. So we share about 7, and then he has 8 of his own down here, which are still private. He's the only one who's tested, and I and my cousin have about 17 or 18, which is quite curious itself, because there's a huge difference between the number I have and the number he has. And of course, we can't know which is more likely to be the pattern without testing more people. So we can average the numbers, and we have an average number of 13, and purely based on that, we can make a deduction that Cleary and Gorman probably split around about the year 600. Like I said, that's purely based on estimating the branching, the age of branching. We need more tests to really be sure we have a robust figure, because actually, do we know if this is the more common pattern, fewer SNPs, or in which case Cleary's would be a family of mutants, or is this the more common pattern and Gorman just haven't actually picked up very many mutations? We don't know until we do more testing. We probably won't do that because it really answers the question that we're looking for. So because big Y testing is expensive, we're probably not likely to pursue this much further in the near time. Although I'd like to know more and try and work out where this branch may actually happen. But it does look as if it's pre-surname. Now, of course, this asks all kinds of questions about the kind of estimates of ages of trees that are based on STR research. So the formulae for working out the time for the most recent common ancestor based on your STR markers. And what I'm finding is that almost all of these are as being too recent. So SNP testing is predicting that many of the branches we thought were a certain age from STR testing are actually much older. But of course, this data is not really robust, we need more, but there seems to be an indication that there are many earlier branching and maybe many people who think that they have an NPE or they are two surnames within one lineage are actually really separate lineages after all, where the branch predates surname testing. So big Y testing, SNP testing can investigate this kind of question. So STRs are great for excluding relationships. They're quite good for suggesting two people are probably related. They're much less powerful for telling you how they're related, when they're related. And that's really why we need to move to SNP testing to get more robust information about this. Here's one example. STRs miss many kinds of data, sort of invisible mutations. Here we have two haplotypes, Hubert and Engelbert, find that they match on these three markers. But after many, many more testing, and it will take many more tests to uncover this, they discover that actually, in reality, Engelbert went down to 24 here, and then another ancestor later on back to 25. There's actually two mutations that Engelbert can't see. And therefore, the real genetic distance between these two is 2 out of 25. That's hidden in STR testing, unless, of course, you test the right people to build the tree in the right way. Then there are parallel mutations. So here's another example for haplotypes here. And the interesting one to look at are these two markers in the end. This is what we call an all four values situation. Because over here, there are two 13s and two 12s, and here two 23s and two 22s. But which one came first? So if this person mutates 22, this person's 23, so when did he become 12? One of these mutations must have happened twice. And actually this is something which I'm finding more and more commonly, that the larger STR lineages I'm looking at become. So it used to be said several years ago that an STR would only mutate once in a lineage. Not true. They do mutate more than once. And therefore parallel mutations can also, again, make building your branches very difficult, or estimating times to the most recent common ancestors very difficult with STRs. What again you'll get from a SNP test research program is you'll get a robust tree, because you will develop a clear backbone tree without the ambiguity that STRs do bring along with them. And a further problem that's related to this is what we call convergence. And so, because STRs go up and down, up and down, up and down all the time, they can move away from each other, so two people can become quite divergent, and they can move towards each other again. And here we have a match list with names Kemp, Jacobs, Cummings in particular, they're the ones I'm interested in, all matching each other. Some people in this group have other matches, Bolton pops up occasionally, Anderson, Adams, Small. And in the early days of doing STR testing on this particular grouping, I'm looking at Kemps, my mother's family from Cavan in Ireland. We began to find that we're getting these people, and we're thinking, well, are they part of us? Are we part of them? Same kind of question that my Gorman match in America was asking. So again, looking at STRs only we think we had a big confused lineage here with maybe overlapping families, surnames being shared, no clear picture. But with SNPs, we can get a clearer answer. And we began to talk about what we call the JAX group, and we call it a surname cluster, because these 5 surnames seem to be distinctive types with their own branches. And we've done big Ys for 4 of them now. We don't have an Adams yet. There's been Adams with Northern Irish heritage, but we have the other 4, and we're finding that actually that confused picture from the STR matching page is actually resolved as the STRs are sorted by the SNPs that each family line has. And I produced from that this consolidated tree. Here we go. I showed a version of this a year ago. It's grown since then, which has these 4 groups. So we have the Cummings, the Kemp, the Jacobs. The Jacobs are, they know their ancestor. He's from Maryland. The other groups don't know the name of their ancestor. They do know they are single lineages. And in the past few months, we've added a small, the first small here. And he again proves once again to be different. So what we see here is that there's a breakup into at least 3 strands round about 750. And the Cummins go off one direction, the Smalls go off another direction, and the ancestor of Kemp and Jacobs in another. Adams we don't know yet, I think is another branch off here. And then, we also know round about this time the Cummins begin breaking up. Round about the year 1400 is when the Cummins ancestor lived, began breaking into several lines, passing his name on to all those descendants. And there's also when the immediate ancestor of Kemp and Jacobs lived, and then more recently, the third one I think, yep, here we go, more recently, sorry, let's go back to that one. More recently, we know that the Kemp and the Jacob lineage begin to break up round about 1650. So they're 2 separate lineages with a common ancestor for about 200 years before. Now these are all estimates based on SNP testing, and again we have to give a very wide margin of error. We're getting a better picture of how these families, these surnames, relate to each other than we did from STR testing. Now 4 of these surnames are found commonly in Northern Ireland. One of them is not Jacobs. That's giving us a clue that these people came from somewhere else. And knowing that the Jacobs-Kemp ancestor probably lived around about 1400 is also saying, well, that's where we need, when we need to look to try and find the possible ancestral name, whoever that person was, of those 2 lineages. So there are a lot of resources. If you're doing SNP testing, a lot of resources online, which are basically tree building resources. That's what SNPs do for genetic genealogy. They help you build your trees. Alex Williamson's great big tree is collecting data for 2 R1b lineages, the P through 12, which includes L21, if you know what that means, and the U106 one I mentioned earlier. There are big trees for both of these now. And it looks like this. This is essentially a list of all the SNPs each person has, but arranged by block. So in other words, this block, all these people share. Then this block, these people. This block is only Cleary and Gorman, and that's us, the Clearys. And so now we know in each of these blocks, there's a branching point here, here, and here. And over here, another branching point for Crawfords. And a new person called Lewis, who just emerged. The red means they're analysing him. We don't know how he fits in yet. So, oh yes, and very interesting, discovered this morning, or yesterday actually, somebody called Lee from Norway, who's in this otherwise rather Irish-looking group, for instance. So, interesting questions there to explore in the future. So, this is run by a volunteer. He spends his time doing it totally for free, for love. But if you're in these haplogroups and you do big Y, you should send your data to him, and he will put you in your correct position on this tree. And this tree links into the haplotree of the human race. You're going to track back your deep ancestral origins, and you can then hang on to this, any genealogical research you do, any STRs you may have done, any private SNPs you may have, to build your genealogy forward from here. So tree building is the key to using SNP data. Let's look at these. FTDNA, let's go back, FTDNA, Family Tree DNA are also doing great work with the tree building. In the last year, they've been expanding their own haplotree, adding all SNPs discovered in big Y tests, which they verify to the tree. It's done manually. It's done by a guy in over there in Houston who you email with your data, and he tirelessly looks at it and tells you if it's okay or not. And if it is, he puts it on the tree. If it's not, he tells you, and you can get more data for him. But this way, they're making the big white text that we do, relevant. Because we discover new SNPs, we can give them to him, to Michael Sager, he sticks them on the tree, and the tree grows. And this then becomes a reference point for anybody who's doing genetic genealogy research on the Y chromosome. In your ectDNA account, on the front page are two buttons. One will be your Y haplogroup. If you click on that, it will take you to your position on the haplotree. This is mine, and these, all these, not that one, but all these SNPs here were discovered originally in me. And then other people, and of course, are then given names once we found they were shared. Last case study before I shut up and you ask me questions. I mentioned the Jacobs people in the big tree I showed you earlier. So the Jacobs people are different to us in that they know who their ancestor is. They just don't know where he came from. They know he appears in Maryland in the 1660s, and they want to know where did he come from before that. So looking for genetic relatives may give a clue as to his origin place. And one of the dreams of SNP research is to begin finding SNPs that are inside the pedigrees. In other words, you have a named ancestor at the top, and then SNPs that appear inside the pedigree, that therefore belong to that named ancestor's pedigree. Which means you can then begin to do test those SNPs in relatives or people with the surname to see if they fit in your pedigree. And of course, this is how SNP trees are built. This one here is found in all these people, so that's the original SNP. This one is only in these, so it must have appeared here. And here's a couple of smaller ones. Only here, so therefore there's a branching point, and so on. And finally ending with a private SNP here. So these SNPs all occur inside the pedigree. So whatever this family is the Doe family, they belong to this ancestor. This one does belong to him, but it may belong to someone before as well. There may be another family still unknown that shares that one. Though at the moment that could also be a tester for all his descendants. But these are inside the pedigree, and if you get these on Y-Browse, give them names, you can then test your family members, or people who have your surname, to see if they belong inside these branches. So, just to finish then, this is the Jacobs tree. And this is how it is as of this spring, when a couple of big Y tests were done. We had a kind of genealogical tree already. We know the names of John Jacobs' sons. Puzzlingly, two of them, there's a parallel mutation in this STR marker. These two share this value, these two share a different value. Therefore, there were difficulties in building an STR tree for this family. But the SNPs are now showing a clear pattern. We found one that's shared to all. Therefore, this is now the John Jacobs SNP. There it is, YP6059. But these are inside the pedigree. They're still unnamed. They belong to branches. We don't quite know where in the branch they belong yet. But the next stage is to test other members of each branch, try and place these in the hierarchical structure. And then we'll do the same with this branch and this one. So they're finding the SNPs to identify not just their ancestor, but the branches of that ancestor. As you see, some of these dotted lines here are people who don't know which branch they belong to. They've done their genealogy back to a certain point. They can't make the leap back to the ancestor or the son of John Jacob they belong to. So therefore, SNP testing, these new SNPs may offer a route for these questions to the answer. And the key, of course, is to find these SNPs inside the pedigree. So just to conclude then, SNP testing may not solve all your problems. I mean, the resolution of SNP testing is medium. It's not very tight, which means therefore you may still miss certain branches. It won't solve every problem, but it's very, very useful indeed for anybody who can't make a breakthrough with STR research. The key thing is to use all mutations. SNPs and STRs work best together. Some STRs also co-occur with SNPs, and then STRs carry on happening since the most recent SNP, and they allow you to build out your genealogy much more deeply. Morris here has been pioneering ways of doing that, of representing these SNP and STR branches on mutation history trees. Go and check out his videos on YouTube and elsewhere. And also I'd like to give a plug for my colleague Graham Holton, who will be speaking at 3:15 today about SNP testing in a more advanced level, looking at how SNP testing can answer historical surname questions. So thank you very much for listening.
Thank you, John. Fantastic. Great presentation. Thank you very much, as always, for making a complicated topic seem a little bit more digestible than a lot of people would. Any questions for John? You have a question down here.
Can you explain what a terminal SNP test would give you compared to ordinary SNP?
Thank you. Actually, thank you for asking that. The question is, what does a terminal SNP test give you? I decided not to talk about terminal SNPs because there's enough complication already. Hunting your terminal SNP used to be something that was pursued several years ago, when the only way of doing SNP testing was single SNPs, and most of the known SNPs were deep ancestral ancient SNPs. And therefore, your terminal SNP in those days would give you your haplotype, your haplogroup. L21, U106, they used terminal SNPs. The new ones are found below them that became terminal SNPs. The problem is every SNP's a terminal SNP. I mean, my diagram showing my one single private SNP, that's the one I know is the most recent in my line, so I guess that is my terminal SNP. But I wouldn't know that if I hadn't tested my cousin. I have a huge block instead. So I would say, I think the terminal SNP is no longer a question of real interest. What's much more interesting is building the SNP chain that helps you build the branches of your part of the SNP tree.
And of course, your terminal SNP today may not be your terminal SNP tomorrow, because as you do further testing, they should really call it the currently terminal SNP, because it really depends on the level of testing you've done. And if you do a deeper, more downstream test, then your terminal SNP will change and shift more downstream down that human evolutionary tree. Mm-hmm. Other questions? I have a question here.
Are there ever times when SNP testing will disprove the kinship that had been shown earlier in the STR test results?
I think it's yes and no is the answer. If you're doing a big Y test, you will already have done an STR test. So you'll actually know already what the general shape of the relationship is. Having said that, I've seen cases where people who, rather like the Ken Cummings thing I showed you, believe that they were close to another surname group. Surname B was close to surname A, and maybe B was an NPE or a branch of surname A, and they then find the relationship was much further back in time. So if you've got a lot of SNPs unique to your branch, that pushes the branching point much further back, and therefore it may disprove a theory about relationship. There's still relationship, it's just much older. So that kind of case does happen, particularly as we, I think, underestimated a lot of ages of common ancestors in the STR period. We find that many of these are actually much older, and therefore people are finding that they're supposedly relationships since 1800, like Sean, my match in America, who thought that I was a Gorman. Actually, we relate much further back. So we did disprove that theory about relationship. Yeah, but actually disproving a relationship at all, probably not, because you probably would have done an STR test beforehand.
A question about your JAX group. Now, 750 is where you think that the JAX are all related to, back at around about 750 AD?
Yes.
Have you heard, are all of those JAX surnames from Ireland? Do they trace their ancestry back to Ireland, or are you finding some of them actually go back to England or Scotland or Wales?
It's a very, very interesting question. It's one of the things we're looking at. The JAX Y-DNA type is Scandinavian. Scandinavian, yeah. So it's a Scandinavian name. They're Vikings, or Scandinavian subdescription. What we don't really know is what was the route taken. I mean, we're with a lot of people with similar, with shared markers in Norway, which date to the early Common Era. So therefore, we can be pretty sure that the ancestors of that group did not migrate in prehistoric times. They probably were part of the Viking expansion. What we don't know is whether they passed through Scotland first, or Great Britain first before moving on to Ireland. We only really find them in Ireland. There are some who claim to be Scottish. When we probe the genealogy a bit, it gets very vague. And the only ones with hard and fast evidence of ancestry, it points to Northern Ireland. And my pet theory is that we're looking at maybe a settlement through a Loch Foyle. I think.
So
Yeah.
one of your main
Very-
goals for deciphering where they came from would be to actually find Jack's surnamed people somewhere in Scotland,
Yes,
but you haven't found them at this point in time.
exactly. That's right. But we're trying, we haven't found them yet. Yeah.
Interesting.
Similar question for your Cummings, because obviously you've got Northern Ireland, you've got Southwest Scotland, and you've got Northeast Scotland. How did they get to Northeast Scotland? Because normally we would be following through Southwest Scotland, and they're filtering either through Perthshire. So you're not any Cummings in Perthshire or anything like that.
Well, we have have Cummings in Aberdeenshire and Murray, but they're not part of the Jacks. So, I mean, the Cummings project shows there are many different Cummings lineages, and we know historically how some of the Cummings got to north of Scotland because they're the Cummings. So some of them track their origins to the Cumming clan. It's Scottish. There are some in Galloway, which maybe could have a connection with the island Cummings, and we're not sure which direction it would be. It could be either way. So yeah, we're working on it. We don't have enough kits yet to really get a robust picture. We do know there are lots of different types. There are also Gaelic Irish Cummings. We have a Gaelic origin of the surname, so I'm very Irish looking DNA. So there's different patterns with all one surname. Because once these people get to America, the names all squish around and they all become anything. Yeah. So therefore you can't tell the spelling of the surname what the origin is. DNA gives the answer. Yeah.
Well, it's hugely exciting work, John, and thank you for coming here and sharing it with us. It's always fascinating to hear you talk. Please, a warm round of applause for John Cleary. Thank you.
Thank you.